Welcome to Mastering Solutions. In this problem, they want us to find the displacement, or the straight line distance from the starting point to the end of the race that Erica rode, which obviously, as we just said, is displacement here. This problem is only tricky because of the way that we have to draw the picture, but let's simplify it to show you what's going on here. So they say that in the first part of her race, she did a 5.2 mile long straight road oriented at an angle of 25 degrees north of east. So we have north, south, east, and west. So the angle they said right here is 25 degrees north of east. And that was 5.2 miles. Then they say that she went due north for another 4 miles. So we have 4 miles. And in miles, what is the straight line distance from the start to the end, as we talked about? So that's here up to right here. So let's finish the triangle right here. So we have two triangles. We have this one, and then we have this larger one. Let me redraw the larger one. So we have right here. And obviously we have a right triangle. And we know that from right here to here is 4 miles. So we're going to use this triangle to figure out this distance, or the x component of this vector, so which will give us this component right here. And then we'll be finding the distance from here to here, the opposite, to find the y component of this vector, which will give us this distance right here. And so this one, the y, plus the 4 together will give us the total distance here. And then we'll be able to solve for this once we have both legs of our triangle. So to start off, let's find the x component first. So x is equal to, we need the adjacent, and we have the hypotenuse and the angle, so we'll be using cosine. So cosine of theta is equal to the adjacent over the hypotenuse. We want the adjacent, so let's isolate it by moving h over. So we have the adjacent is equal to h cosine of theta. So if we plug that in, the h is 5.2 meters times the cosine of 25 degrees. 25 degrees. So now we have 5.2 times the cosine of 25 gives us 4.71 miles. So 4.71 miles. So this, let's replace the x for 4.71. So 4.71 miles. Now we need to find the y component. So the y component of the triangle is the opposite, and so we'll be using sine. So sine of theta is equal to opposite over hypotenuse. Doing the same thing, move hypotenuse over, gives us the opposite is equal to h times the sine of theta. So now we have 5.2 meters is equal to sine of 25 degrees. But that only tells us this part from here to here. So we can actually just add in the 4 miles, and that'll give us the total leg from here all the way down to here. So now we have 5.2 times the sine of 25 plus 4 gives us 6.197, so 6.20. 6.20 miles. Sorry, let me give you a little more room. So now let's redraw our triangle one last time. So we have, this one is 4.71 miles. And then this one we said is 6.20 miles. And as we already discussed, we'll be using Pythagorean's theorem. And we have c squared is equal to a squared plus b squared. Isolating c by square rooting both sides, c is equal to the square root of a squared plus the square root of b squared. And so now when we plug that in, c is equal to the square root of 4.71 miles squared plus 6.20 miles squared. And when we plug that into our calculator, we have the square root of 4.71 squared plus 6.2 squared, 7.786, so 7.8 miles. So C, or the distance that she went from start to end, or her displacement, was 7.8 miles.